Yeah, that's what it was.
Everything else has been awesome. It's been crazy busy. Thankfully, hired me to Oculus last week. So now I'm handling a lot of it. Just keeping me very, very busy. That's awesome. It's very interesting.
Hi everyone, thanks so much for coming. I am the author of a book called The Paper Prince, Journeys in 3D Printing, and it's a storybook about 3D printing robots, and all the objects in the story can be downloaded from a URL.
When the time comes, go over there and aim the camera.
We have a booth that's just at the other side of this curtain here. And we can chat more, and
Okay.
we're available. So for those of you who speak and all that kind of stuff, Leo has his own Twitter handle.
Yeah, if you're comfortable.
Here's a little bit about the book. I tried to really focus on the images as well as the objects. And a little bit of background about me. I'm a professional product designer. I've worked for a firm called Smart Design as well as other firms. I've worked on robots, things like really serious robots. This is a floor-cleaning robot that I worked on design of. And I also have worked on robots in universities. So this is Simon, and he's a robot at the Georgia Institute of Technology. It's created to study how we as humans might interact with machines. This is Simon's cousin, his name is Curie. Simon was featured in the New York Times, and here's a little bit of 3D printing that took place when we were developing Simon. And when I did this work, as well as the work that I do for clients, 3D printers were really, really expensive, and we only did this on special occasions for special projects. But when the desktop printers started appearing, I realized that this was a really important moment in history, and I decided that I wanted to do a project about it. And I realized that I wanted that project to be really visual and to really tell stories about how 3D printing is going to be in our lives. So this is what the cover of the book looks like, and all the objects and characters can be downloaded 3D printed. And began with character creation, and story development was really a priority. So here we have Carla, who is the main character, and this story is a little bit my story, really. And Carla meets Leo, who is a 3D printing robot, and he says, "Draw me a sheep." And how many of you are familiar with The Little Prince?
Yeah.
Few hands. So that's my homage to Antoine de Saint-Exupéry. I loved The Little Prince as a kid, and I still have that book with me. So Leo is the maker prince, and he says, "Draw me a sheep." And then Leo, the way that I built the story was that I wanted his anatomy as a robot to really explain how 3D printing works. So he has a filament spool of plastic on his back, and he has a tail with a heated nozzle at the end of it. And when he gets the sheep drawing, he scans it, and then he goes through and he actually builds it. And then in the book, every time there's an object, there it is. And so if you go back to the booth, you'll see I actually have 3D printed versions of this very sheep. And then some of the other stories, we have Inventor, and he makes his own kind of robot dog. We have a jewelry designer, and she has a micro factory robot. We have a little girl, and her mom has a 3D printer at home and lets her download toys. So she makes these musical instruments. We have a fellow who wants to customize things in his home, so he makes them. He goes to a store and gets it downloaded 3D printed. There's a character called Nathan, and he lives by the beach. So he gets his feet scanned, and he gets his own 3D printed beach sandals, and he can leave footprints that are like octopus tentacles. There's a chef, and there's also a kid who moves with his family to the moon. And a lot of this stuff was really based on real research. So there has been research about using 3D printers to modify the lunar dust material in architecture. So this seems very fantastical, but a lot of it is really inspired by things that I've been reading in science and technology.
Like that picture.
The most exciting part of this project has been that people all over the world have been downloading and 3D printing the objects. The sheep is by far the most popular. And another thing that people will do is they'll kind of add their own spin and be creative about it. So we see a lot of the sheep like the one that you'll see, and I was waiting for the day that someone would make the black sheep, and it happened. And I really love this picture, because not only is it the black sheep, but he's really nefarious, and there's something going on in the background. And people print the Carla character, they print the jewelry. There's a lot of videos out there, and there's one fellow who's even starting to do some fan fiction. So he'll tell these little stories. Like here's Leo, and he's supervising a new dress for Carla to be built in the factory. And here's Leo, and Carla's got some kind of scanner dress prototype.
Maybe if we can get this
here's
working,
Leo, he not only prints in plastic, but he can
that's
print
a Canon, right? So the eyeglasses
so I really love those.
All that shit
but what I really want to share today was a little bit of what happened behind the scenes and how I created the objects. This is what happens when the 3D printer goes wrong. So those of you who have a 3D printer, I think, are very familiar with the black spaghetti. But that's okay. We're pioneers. That's what happens. So the sheep was really, a process. All of the objects in the book, I'm a big believer in drawing. So I worked with a really lovely assistant who's a product design student, and we spent a lot of hours just drawing and thinking about how can we capitalize on what the 3D printer can do. So we have a lot of drawings that include sheep that has like a hole pattern that might use algorithms. We settled on this kind of cloud bubbly. And I use Rhino as my modeling tool. Rhino is a 3D printing package. It's something that we've used as professional designers, but if you're just getting started, I would recommend Tinkercad or some of the Autodesk 123D suite. And then I spent a lot of time making test prints. So here's one of the first test prints of the sheep. It had white legs and they were all attached. And you know, once I did that, I would make these subtractions and connections. So this image shows you that you know, what I tried to do was have things that are in different colors. So the sheep has black legs and a white body, and I actually have these connections where you can put it into the body and they snap in. And you know, I build the main part of it, and then I do this sort of subtracting of where the negative space from, say, the legs is going to be. The Leo character was a really interesting process because I've designed robots professionally, and I thought of him kind of the same way, if this were really a robot. So this didn't make it in the book, but it's one of my favorite images, and it shows how Leo's anatomy explains 3D printing. So he has a heated nozzle, and he has this articulated tail, and he has a scanner in his eyes. And you know, as a designer, what I really like to think about with robots is what the relationship is to the person. So there was a lot about gesture. How would he take the drawing? How would he hand you the print when he was done, which would be like a really important moment. And so these are some of the drawings behind the scenes, like maybe it comes out of his tongue, or maybe it's on his head or on his arm. But we wound up settling on, you know, the tray on top of his head, and the tray being able to move and take a drawing and things like that. So, you know, and I really wanted these objects to be kind of satisfying and fun and playful. So rather than make them just static, I made movable parts. So this is what a top view of the 3D file for Leo looks like. And again, you can see I use these interlocking joinery. So this is something I really like to use a lot, where you see, because the plastic will just bend a little bit, and then you can see that there's an opening at the very end of the opening. It can kind of expand and click into place. So once you get a system like that together, you can kind of apply it to other things. Another thing that I knew I wanted to do was I wanted to include the idea of using mathematics as a basis for creating forms. So one of the characters in the book is named Stephanie, and Stephanie makes jewelry. I'm actually wearing some of the jewelry that Stephanie made today. And Stephanie's jewelry is based on a formula called Fermat's spiral. So what I did was I went back to some books that I had actually from my days in graduate school, where I was looking at graphic design and making graphical patterns. And I revisited some of those formulas, and I learned that Rhino has a plugin. And the Rhino plugin
How that throwing away the trash
is a
sound.
Python language. So what I was able to do was play around with some of the book that I have is called Mathographics. And you know, again, it was really just for two-dimensional images and making graphic design. But what I was able to do was just add another dimension to it and kind of play around with it. So this is one of the original forms that I generated for the jewelry. And you know, this wouldn't work because it's, you know, thousands of discrete objects, and you really can't print that. But what I did was I just kind of played around with it and tweaked the shapes and moved. You know, this is a cylinder that is being moved around as well as scaled vertically and in the X and Y. And you know, what I eventually wound up being able to do was get them to a place where they all touched each other. And then in the 3D software, what you can do is kind of fuse it together, so it becomes this one piece. Another thing I really wanted to do was give everyone a sense of what the entire array of materials would be. So it was important to me to include metal, even though that's not something that you might have with your home 3D printer, but it is something that the Shapeways service could do. Shapeways is also here at Maker Faire. And you know, I really love this because I could either print this at home in plastic, or I have a link on the Leo the Maker Print site where someone could buy this jewelry in sterling silver. So that's a lot of fun. But you know, in looking at the whole array of materials, I'd been reading a lot of research about 3D printed food. And so it was very important for me to include this in the book. And what I wound up doing is I contacted the department at Cornell University that I've read about, and they're called the Creative Machines Lab. And so this is a little glimpse of some of the work that the Creative Machines Lab at Cornell does. And they're really experts at food. So they were able to explain things to me. Like, one of the key things they explained is that food to be 3D printed has to be what they call 2.5D. So not 2D and not 3D, but 2.5D. And what they mean by that is it really can't have any overhangs because the food will sag. So you'll notice that none of these things have overhangs. I mean, the eyes of the octopus sort of a little bit, but that's an octopus made with cornbread. At the bottom of the screen there's a space shuttle made out of Velveeta, and there's chocolate, and there's also a scallop space shuttle that's very small. So what I first did was, I called them up and I said, I'm working on this project, and then we brainstormed together, and we were able to, as a team, kind of sketch these different ideas. And we looked at games, and we looked at, interlocking things like Lego. But we wound up and we really wanted to do the man on the moon. We wanted to do the moon made of cheese. But we decided that it would be very tricky to get the resolution. And we wound up settling on the 3D printed cheese with like a cheddar and like a white cheese. These are actually plastic, but we did have cheese FedEx to us. But we decided that this communicated a little bit better. And one of my favorite stories about the development of the book was how we did the title. And the title was something that I knew I wanted to be 3D printed. And the obvious thing would be to take the letters and just kind of extrude them. So you just lift them up. And that would look like this, which is okay. And then we looked at some other versions. Here, the Maker prints, it's a little askew. But I really felt like this was an important part of the book, and we wanted to experiment a lot. And this was a great example for me about how experimenting can lead to kind of happy accidents, where you think that your design is going to be one way, and then because you play with the material, it emerges in another way. So I said, well, let's try these tapered letter forms. So this is a version where the letters, they're fatter at the bottom, and then they get kind of thinner at the top. So it's kind of an extrusion where everything is tapered so it's fatter at the bottom. And what wound up happening and this is another thing, any of you have 3D printers are familiar with the printer kind of quitting in the middle of things. Like either the filament gets stuck or it doesn't extrude. So that was happening with one of our tapered letters, and it stopped at this point. And I looked at my assistant and we said, that's kind of cool. And we thought, this is really beautiful, sort of just as it is. And so what we decided to do was we tried to replicate it on purpose. And we actually wound up building the file, and the title looks like this. So that's where the title came from. And it's really fun to me because people will ask me, what is that font? How can I get that font? And I said, well, it's actually not a font. It's exactly what happens when you do this crazy thing and you taper it and then you stop the printer. And so that's what the title looks like. And I've loved it so much that I even use it as the logo. I mean, I think I might have it on this t-shirt. But this is the logo that we use on the website and on cards and things like that. So, the last item that we have in the book is the hamster house on the moon. So, and again, this was very inspired by research that I had read where there are actually architects who are experimenting with 3D printing architecture on the moon. And we decided we would introduce it as a hamster house. So as a designer, it's very important to know your user. And I felt like we can't design a hamster house unless we know a hamster really well, and we don't. So Alexa, who is my lovely apprentice, she said, well, my roommate and I really want a pet. And I said, oh my gosh, we're going to the pet store right now. So we went and we adopted Weenie. Weenie, and this crowd will appreciate that. Weenie is short for Arduino. So that's Weenie. And we got her, and I made sure that Alexa really lived with her and really understood, what are the spaces that she needs, what might be, what needs to go inside it, where does she eat, where does she sleep, that kind of stuff. And we also bought the competitive products. So this is the OVO Habitrail. And, we really try to learn. Like, as designers, it's just important not to try to reinvent the wheel every time. And I also look for inspiration. So this is the house from a movie called Oblivion. And somehow this just always stuck in my head. And I felt like this is really this is the house that would be on the moon. This is the future tech house. And so these are some of our sketches. Again, inspired. And we kind of thought about, like, could there be a wheel in there? Would the water bottle be like that? And then we also have to think about practical things, of course. So we, would go to the hardware store and we would pick up all the things that we could find that were interlocking pieces. And we decided that we would make this house kind of modular. Like, you can see the kind of figure-8 looking things. We thought, like, you could have 3 or you could have 4 or you could have 15. Like, let's develop a system that's modular. And in order to do that, we needed to make sure we had these connections that could work in many different configurations. So we worked a lot. A lot of the focus of this design was around the mechanics of how those shells would snap together. And then these are some scaled models of the hamster house. So we have these kind of ends that snap together, and then we have these pipes that go in the top and will connect one floor to the next floor. And then this was the final result. I have to say this is a really tricky one because the clear plastic is not something that's easy to get. I mean, you can buy clear plastic, but it comes out cloudy when you actually print it. So this is a little bit more of an aspirational project that I tell people is actually probably hard to replicate at home. I used a service called iMaterialize, which is a lot like Shapeways, and they often a polished clear plastic as one of their things, but it is quite expensive. The other models are all very accessible and easy to do very quickly. But that's what I wanted to share with you today. We have a website for the book. It's called leothemakerprints.com, and there are links there to all the objects from the book. And I think I have 5 minutes if anyone has a question.
Visual routine?
And I don't know if I can hear you, but I can try. If there are no questions, I can show you Thingiverse, and I can show you our website.
And sometimes these pinch, I can do my best not to do that to you. But if it starts to,
this.
please let me know.
It tells you a little bit about the story. There's a link to Amazon. We've gotten a great amount of press. Wired wrote about us, Fast Company. The Telegraph in London called us one of the top 12 best gadgets, even though we're not a gadget, really.
That's fine.
But there's a link to where you can learn more about the book. There's a link to make the objects. There's a link to Thingiverse, which if you're new to 3D printing, I recommend spending some time on Thingiverse. Thingiverse is a website that actually allows you to post and download models. So all the models for the objects from Leo the Maker Prints are available on Thingiverse, and you can see a picture of them, and then there are instructions for how you put the pieces together and how you print the pieces, etc. So I think with that, I will let you guys move on to your next speaker. Unless you had questions. Okay, thanks so much.
Oh, of course, of course.